concept that we have to learn is about electric potential, and this concept is very, very similar again to the concept of gravitational potential, except for the fact that it carries both positive and negative signs. So electric potential is being defined as the work done in moving a unit positive test charge from infinity, that is outside the electric field, to a point inside the field. Let's say this is a point P, which is at a distance R. Generally speaking, we are trying to find out the work done. We already know how the electric field strength variation is like. Work done is force into distance. And work done for a unit charge would be electric field strength into the distance moved. And since electric field strength is variable, so to find out the work done, we would have to find out the area under the electric field strength graph from infinity to the point R where the charge particle, the unit positive test charge, is moving. And the area is being found by using integration. This derivation is not part of your syllabus. It's just to make you understand how we arrive to the formula of electric potential. So this is from infinity to R. The negative sign is being taken because you're moving a positive charge, which it experiences a repulsive force. And since it experiences a repulsive force, so that means the force and the displacements are in the opposite direction. To account for that, we put a negative sign over here. And then we will try and simplify this integral. I've taken constants outside, x power minus 2, integrated it by using a power formula, put down the limit. So after simplifying it, I get myself electric potential as Q over 4 pi epsilon naught R. But yeah, this is a formula, and we know 1 upon 4 pi epsilon naught could also be replaced by K. The other thing I would want you to identify is how we've already talked about the electric field strength variation for a metal charge. It behaves like a point charge, but only till you arrive to the surface. Inside the surface, there's no electric field because charges on the opposite ends would cancel each other fields out. How would the electric potential graph would be varying? This would be lesser steep because it's divided by R. This is divided by R squared. So it'll give you smaller value, and divide by R would give you relatively bigger values. And important thing is that there would be a flat line over here. That's because you would continue to do work in bringing a unit positive charge as you keep on moving towards it. But you realize that as you move inside the sphere, you don't need to do any excess work, any extra work, because there's no field inside. The charged particle inside the sphere doesn't experience any force. So obviously no work needs to be done on it to make it move.